In this video, we are going to review for the first exam. Now, in the first exam, some things to remember. It's going to be 25 questions. You have 90 minutes to take the test. It is available on the Monday of week 8 through the Wednesday of week 8, only those days. You have one attempt. It is closed book. You may use 2 to 3 pages of notes. You may use the instructor provided formula and conversion sheets if you want to print that out and then have yourself 2 little pages of notes. The Desmos calculator is allowed, so I believe there's a tab that you can open that up as you go. And it will be proctored through Respondus. There is a sample one that you would want to have practiced on a little bit before you take the real test. So if you haven't done that, make sure to do that. So there's just a little bit of information that you got so you know, okay? So I'm going to do some sample questions similar to what you should expect to see on the test. So these are good to review. I will send you a copy of this, like a blank copy so that you have it and you could follow along and try it yourself. So let me kind of remember to do that here. I'm just gonna make a little blank there for you and I'll send that to you. This test, you should be studying by going over some of the old questions, old homework. That would be helpful. Okay, first question. A car rents for $175 a week plus 65 cents per mile. What is the rental cost for a family of 4 on a 2-week trip of 1,000 miles? Now, it's $175 per week. So let's consider the fact that 175, if we get charged that every week for 2 weeks, that is $350. Okay. Now, we also have to consider that we have traveled 1,000 miles. So 1,000 times 0.65, just move that decimal place 3 places over, and that would be $650. And so our total for traveling 1,000 miles and renting it for 2 weeks, just add those up and it would be $1,000 for renting the car. Okay, so that's question number 1. Let's look at question number 2. 10 people bought textbooks. The electronic rental was $49.95 and a new hardcover book was $169.95. 5 people bought the used book for $89.95. What is the best estimate for the total of all 10 books? Now, if 5 people bought the used book for $90, okay, let's take care of that. Okay, 5 times 90 is $450 or for those 5 books. Now, they didn't really tell us what the other people bought, okay, the 5 other people. But let's say that all 5 of them bought the new hardcover book. Let's just change that to 170. Okay, so 170 times 5 is 850. But what if the other only bought the electronic rental? The 50 times 5 is 250. Okay, so we know for sure that they spent 450. Okay, so 450 plus 850 is 1,300. 450 plus 250 is 700. So we know it's got to be most likely somewhere between 1,300 and 700, somewhere in there. And most people probably bought the hardcover book. We don't know for sure, but I think a good estimate would be C, somewhere in between there. We could even average those. 1,300 plus 700 divided by 2 is 1,000. So the one closest to 1,000 is 1,100. So I think it's a good estimate that that's what all 10 books cost. Okay. Let's take a look at this one. We've got this circle graph. There is a scale or a key, I guess you call it, over here that tells us what each wedge is worth. Most important problems for high school teenagers is they want to do well in school. That's 12%. Social pressures and fitting in is this color. That's 23%, and so on. It says the circle graph shows the most important problems for over 18 million high school teenagers in a country. Without using a calculator, estimate the number of teenagers for whom drugs is an important problem. So see how drugs is 23%? Let's round that to 20%, okay? Let's round the other one to 18 million. So 18 million times 20%, which is 0.20, just because we want to estimate and we can do it, do it easily ourselves. We would bring down the zero. We would multiply by 2. So 1, 2, 3, 4, 5, 6. 2 times 8 is 16. Carry the 1, and that's 3. And then we move the decimal place here. Okay. So what's a good estimate? Well, if we put our commas back in, it looks like it is the 3,600,000 mark, and that would be A. Good 4. It says identify the digit in the tenths place and then round it to the nearest tenth. Now, if it has that TH on it, that means that it's after the decimal place. Now, the number 10 has 1 0. So we would be one place after the decimal. So this 0 right here is in the tenths. And then when to round to the nearest tenth, we have to look after it, that 8. If it's 5 or greater, we're going to go up. So it's going to be 2,167.1 would be rounded to the nearest tenth. So there's question 4. Let's look at question 5. Identify the digit in the thousandths place and round to the nearest thousandth. The thousandth place, it has the TH, so it's after the decimal, and the number 1,000 has 3 zeros, so go to the third place, and that's this 4 right there. Okay, so our 4 is in the thousandth spot, but if we want to round to the nearest thousandth, just look to the 6 there and bring it up. That 4 becomes a 5. So 2,167.085 would be our answer. Let's look at question 6. Identify the digit in the hundreds place. You notice it doesn't have the TH there. So we actually want the hundreds. So 100 has 2 zeros after it. So we need to have 2 things after it. And so this right here, that number 1 would be our hundreds place. We want to round to the nearest hundredth. Behind it is a 6. So it is going to go up. And if we said it out loud, we should say 100. I have 2,200. And that's a good way to identify that you have rounded it correctly. Let's look at question 7. Identify the digits in the ones place. Again, it doesn't have any THs. It's only one ones place. It is this place right here to the left of our decimal place. So that's 7 is in the ones place. And the nearest whole number would be rounding to the ones place. So if they say whole number, you don't want the decimals to appear. Now behind the 7 is a 0, so it's going to be left a 7. So our answer is 2,167, and that would be to the nearest whole number. Let's look at 8. Convert 42 pounds, 8 ounces to pounds. Well, we already know we have 42 pounds. So it's going to be 42 point something, but we have to figure out what is that something. So all you're going to do is take 8 divided by 16. Now, why is that? Well, 1 pound. Sorry, let's make that prettier. 1 pound is equal to 16 ounces. So if we only have 8, what part of 16 do we have? That's a good way to think about it. So 8 out of 16, if you put that into a calculator, you're going to get 0.5. So we are going to take off the 0 and replace it with 42. So it becomes 42.5. So that is question 8. Let's take a look at question 9. Convert 195.3 pounds to kilograms. The facts we want to know is that 1 kilogram is 2.2 pounds. Okay, so I'm going to set that up as a fraction. 1 kilogram is 2.2 pounds. I can write that right. Okay, there we go. So do you see how pounds I've put in the denominator? So put your 195.3 pounds in the denominator there and put your X or your, question mark in the top. Now, to solve a proportion like this, the easiest way to do it is to cross multiply, and then whatever number you haven't used, you're going to divide by. So we're going to multiply and then divide, or cross multiply, and then you'll end up dividing by the 2.2. 1 times 195.3 is 195.3. And x times 2.2 is 2.2x. You got to divide by 2.2. So since we're going from a smaller unit pounds to a larger unit kilogram, you're going to end up dividing. So it would be 195.3 divided by 2.2. So 195.3 divided by 2.2. And I'm going to see how the digits were to the nearest tenth. So I'm going to continue to go to the nearest tenth. Initially, my calculator says 88.772. And so if I go to the nearest tenth, it would be 88.8 kilograms. And so remember, it takes more pounds to make 1 kilograms. So when converting, the kilogram should be smaller. Okay. So there is question number 9. Question 10, convert 65.8 kilograms to pounds. Now we're going backwards. So remember, 1 kilogram is 2.2 pounds. So if you do that same fraction, 1 kilogram is 2.2 pounds. So if I have 65.8 kilograms, how many pounds is that? Our X, our unknown, our question mark is in the wrong, the different spot, the flip spot. But we're still going to cross multiply. 1 times X is just X. And so it's going to be 65.8 times 2.2. 65.8 times 2.2. Your calculator would read 144.76 pounds. But again, everything we've done is to the nearest tenth. But please follow the instructions. If they don't say it around, just enter 144.76. But most likely you're going to need to keep that 1 decimal place. So 144.8 pounds would be good. Okay, so that is question 10. Question 11. We are going to convert 45 milliliters to tablespoons. So the fact you want to get or use is that 1 tablespoon is equal to 15 milliliters. Okay, so I'm going to write that as a fraction. 1 tablespoon is 15 milliliters. So how many tablespoons would 45 milliliters be? So again, you're going to cross multiply. You're going to get 45 equals 15x. So that tells me I need to divide by 15. And so our answer is 3 tablespoons. So 3 tablespoons is 45 milliliters. Now let's go the opposite way. Same fact. 1 tablespoon is 15 milliliters. So 1 tablespoon is 15 milliliters. So 18 tablespoons is how many milliliters? So you can see we're going to cross multiply. We're going to get x equals 18 times 15 because we're going from that larger unit tablespoons to our smaller units milliliters. You'll end up multiplying. 18 times 15 is 270 milliliters. So that is how you do question 12. Question 13, convert 182 grams to kilograms. Well, you can find the fact that a kilogram is 1,000 grams. So that's the fact we're going to use. There's also a little thing I'll show you in a second, but you can just write that 1 kilogram is 1,000 grams. So how many kilograms would 182 grams be? Okay, we're going to cross multiply. So we're going to get 182 is 1,000x. So we got to divide by 1,000. Because a kilogram is the larger unit, you need to divide to convert that smaller unit into that larger unit. And so it is going to be 0.182 kilograms. Now, another silly thing you might want to have memorized is kittens hide down under dad's car motor. Let's make these ones in capital. That's helpful. If you go from our unit grams to our kilograms, so you'll see that if we count the jumps, it's going to go 1, 2, 3 places to the left. So our decimal place would go 1, 2, 3 units to the left. So 0.182. So either way is a good rule of thumb. Okay, let's take a look at question 14. Convert 24.6 degrees to Celsius to degrees Fahrenheit. So we want to be able to stick in the Celsius and get out the Fahrenheit. So the formula you want is that the Fahrenheit is 1.8 times the Celsius plus 32. So the Fahrenheit would be 1.8 times 24.6 plus 32. Now, following order of operations, 1.8 times 24.6 is 44.28. And then you add on 32. And when we do that, that is 76.28 degrees Fahrenheit. Okay, so that is how you convert from centigrade to Fahrenheit. But now let's go the opposite direction. The formula that you want is the centigrade is the Fahrenheit. We're going to take off the 32 first, then we're going to divide by the 1.8. Okay, so the centigrade is 100.2 minus 32 divided by 1.8. So let's do what's in the parentheses first. So 100.2 minus 32 is 68.2. Get that number and then divide by 1.8. When we divide, we get 37.8 repeating. So we should make that 0.8 would round up to a 0.9. Okay, so that is how we go from Fahrenheit to centigrade. Let's talk about prime factorization. Let's start with 63,504. Now I know that it is divisible by 2. So if it's divisible by 2, I'm going to make a little factor tree here. That's 2 times 3,000 or 31,752. It's still even. I can divide by 2 again. I get 2 times 15,876. It's still even, divided by 2 again. I get 7,938. Still even, divide by 2 again. And now I get a number that isn't even. Now, there's some tricks you can find. Um, if the digits of the number add up to a number that is divisible by 3, the number itself is divisible by 3. So if you see here, 3 plus 9 is 12, plus 6 is 18, plus 9 is 27. 27 is divisible by 3. So I can definitely divide that by 3. And I get 1323. Add up those digits, you get 9. Still divisible by 3. Do it again. And now we get 441. Now, 441, we have to try some other tactics. Let's see. 4 plus 4 is 8 plus 1 is 9. Oh, we can still divide by 3. I'm running out of room here. And I get 147. And that adds up to 12. We're still divisible by 3. And then 49 is 7 times 7, which are prime numbers. Now, how do we write that better? Okay, so let's look. We have 1, 2, 3, 4 twos. So that is 2 to the 4th power. And then we have 1, 2, 3, 4 threes. So that's 3 to the 4th power. And then we have 2 sevens. So that's 7 to the 2nd power. So that's the prime factorization, the way that you would want to write that number. Okay. For the next one, maybe I'll try to write a little smaller. Let's do 38,808. Now I know it's divisible by 2 because it's even. So let's divide it by 2. And I get 19,404. I'm sorry I do that so much. Divide by 2 because it's still even. I get 9,702, still even. Divide by 2. And then I get 48,000. I don't. I get 4,851. Okay. Now, if you add up those digits, 4 plus 8 plus 5 plus 1, it totals 18. The number 18 is divisible by 3. So I know I can divide this by 3. So 4,851 divided by 3 is 1,617. Now, if you add 1 plus 6 plus 1 plus 7, you get 15. 15 is divided by 3, so or divisible by 3. So let's divide that by 3. I get 5,039, which is not divisible by 3. So then we have to think about how could we break down 5,000 or 539? Well, there's some tricks, okay? If a number ends in 9, I would probably try next 7, because 7 times 7 is 49. So if it's could be a 9 related thing, I would try 11. Um, because maybe we could multiply that, that's what that's what you would try. So I'm first going to try 7. Just going to hope for the best. 539 divided by 7 is 77. That's great. So that's 7 times 77, and then we've gotten small enough like 77 that we can break that down pretty easily. That's 7 and 11. So if we count, there are 3 2s, so that's 2 to the 3rd. There are 2 3s, so that's 3 squared. There are 2 7s, so that's 7 squared, and then that is an 11. And you can check on a calculator. If you put that in, you better get 38,808. Okay. Now that is the prime factorization. So I'm going to move those prime factorizations. Let me copy them down here because we're going to need it for the next problem anyway. Okay, I think we might, yeah, we're going to need it both places. Wait a second. I'm going to copy one more time. Okay. So the greatest common factor, we're going to use the smallest factor power that they have in common. Okay. So they both have twos, and we're going to use the smallest value. So that's 2 to the third. They both have threes. The smallest is 3 squared. And they both have sevens, and that's 7 squared. Okay. So for the greatest common factor, you use the smallest thing because that's what they have in common. So it's weird because you see the word greatest, but you're using the least power. Okay. And so it's 2 to the third times 3 squared times 7 squared, which is 3,528. Now, they should both divide evenly into 63,504 and 38,808. So let's just check that. 63,504 divisible by 35,028. Yes, 18 times. Perfect. 38,808 divided by 3,528. It does 11 times. Perfect. So there's our answer. Okay. Now, the least common multiple, we have to use the highest power. And if one thing has something and the other doesn't, we have to account for that. Okay. So what do I mean by that? Well, our twos, the highest power is 2 to the fourth. Our threes, the highest power is 3 to the fourth. Our sevens is 2 of them. And we do have to have that 11. Okay. Because we're looking for a number that they both will divide into. So think that at least common multiple is these numbers or larger. Okay, so let's check. So if we do in our calculator 2 to the fourth times 3 to the fourth times 7 squared times 11, we get 698,544. And these numbers up there should be divisible into that. So if we divide that by 63,504, we get 11. Perfect. If we divide it by 38,808, we get 18. Perfect. So perfect. It worked. Okay. So the least common multiple will be those numbers or larger. The greatest common factor will be those numbers or smaller. So just keep that in mind. Okay. Now let's talk about some signed numbers. For this one, when adding signed numbers, if they're the same sign, add and keep the sign. Different signs, you are going to subtract them and keep the sign of the larger value. So we're going to subtract 8 from 9 and get 1. But since 9 is larger, its absolute value is larger, we're going to keep that sign. So that's why it is -1. Another way to think about it, if we are 8 degrees on a thermometer and we drop 9 degrees, we are down now in the negative territory. We were at the -1 spot. Here, same thing, different signs, subtract them, keep the sign of the larger thing. 12 is larger than 8, keep that sign. Now, two negatives here flip you to the opposite direction. We think of the opposite of a negative is a positive. So I'm going to think of that as -14 plus 6, which is -8. Think of this as 8 plus 3, or 11. Now it says subtract 7 from 9. So that's 9 minus 7. Multiply this difference by 5, and then square your answer, that product, okay? 9 minus 7 is 2. 2 times 5 is 10. We're going to square that to answer that product, and 10 squared is 100. So your answer is 100. Using order of operations. Now, order of operations is please excuse my dear Aunt Sally. I think of it as 4 levels. I say the number 4 and I write it. Sorry about that. Okay, but anyway, let's go 1, 2, 3, 4. Okay. So you're going to do any sort of parentheses or grouping symbols Then you are going to do any exponents. Then you multiply or divide from left to right. Then you add or subtract from left to right. So there's really kind of 4 steps as you go through the process. So what I see here, I don't see any grouping symbols, no parentheses or anything. So the next step is to do the exponents. So 8 squared is 64. 2 squared is 4. Now I'm going to do any multiplication and division from left to right. So 16 divided by 4 is 4. 4 times 7 is 28. And now it's just subtraction from left to right. 64 minus 28 is 36. Minus 2 gives us a final answer of 34. So that's that one. Let's do another order of operations. Now, this time I see some grouping symbols. So let's focus in and hone in on this area right here. So we treat it like it's its own problem. 2 negatives there make a plus. So that's going to be 6 plus 3. 6 plus 3 is 9. And now that we have no more grouping symbols, we are going to do multiplication and division from left to right. The only multiplication or division is this 2 times 7 or 14. And then we're going to add and subtract now from left to right. We get negative 11 plus 14 is 3. Let's take a look at this one. It says, what is the difference in lifespan between someone who eats red meat more than twice per week? So that would be uh, eats red meat more than twice a week. So that's at the -5 spot. And someone who eats 5 servings of fruits or vegetables daily. So eats fruits eats 5 servings of fruits and vegetables daily is at the 3 spot. And so it is the difference between them is 8. Now look, we should check, and it's negative because of the fact from here to here is 8. So ready, go. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that would be your answer. And actually, let's see. The difference between someone who eats, so it would be -5 minus 3 is -8. Yep, we're good. Okay. What is the decimal form of 5 ninths? Well, 5 ninths is 5 divided by 9. And if you put that into your calculator, you're going to get 0.555 repeating. Now, watch if they want us to round it to a near certain spot. Let's say they wanted us to round to the hundredths. That would be 0.56 because all those fives behind it would round up. So watch that. Let's look at question 28. Is this a true statement? Okay, so 1/8 plus 1/10. Let's do that math. To get the addition of any fractions, we need to have a common denominator. 8 and 10 both go into 40. So let's multiply by what we need to change them into 40. So I'm going to multiply these by 4 and these by 5. And so I'm going to get 5 over 40 plus 4 over 40 is 9 over 40, which doesn't reduce. Now, 2/18, they are both divisible by 2, so that is 1/9. So the answer is no. 9 over 40, if you were to check it on your Desmos calculator or on your own calculator, 9 divided by 40 is the decimal 0.225. 1/9 or 2/18 is the decimal 0.11. Definitely not equal to each other. So that would be a no. Let's take a look at question 29. Is 5 ninths divided by 10 the same as 1/18? 5 ninths divided by 10, make the 10 over 1 is the same as 1 over 10. And then we can either multiply the tops and the bottoms, 5 with 1 and 9 with 10, and then reduce. They're both divisible by 5. You get 1 over 18. Or you can notice they're both divisible by 5. I can multiply after I reduce, and I still get 1/18. So that is a yes. Let's take a look at this one. For this one, if you're going to do it by hand, I would suggest making them into their improper fraction form. Okay, so 2 and 5/9, 2 times 9 is 18. 18 plus 3, or 18 plus 5, I'm sorry. 2 times 9 is 18 plus 5 is 23. And then our second fraction, 4 plus 4 times 1 is 4 plus 3 is 7. To divide fractions, we're going to keep the first one, change the sign and flip. Keep, change, flip is a good little silly thing to remember. And if you multiply the tops, 23 times 4 is 92. 9 times 7 is 63. Well, we do have 63 in there. That's a good sign. 92 divided by 63. It goes in there once. And you are left with 29. So it is 1 and 29 over 63. So this one is a yes. They are the same. Simplify this expression. If the bases are alike and you are dividing, the rule is keep the base, subtract the exponents. So we're going to keep the base 7. 8 minus 3 is 5. So that would be 7 to the 5th power. Let's talk about scientific notation. We want the decimal to land in a spot that our front number is a number between 1 and 9. So we want this to be 1.297. Now, how many places did we have to jump to put the decimal there? 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have a very large number. That's 10 to the 9th power. Now let's do the opposite. Okay, so we want our decimal there, 9.735. We want our front digit to be between 1 and 9. How many places did we go? 1, 2, 3, 4, 5 places. And that was a small decimal. That's a negative exponent, so it's -5. Now let's go the opposite way. So this is positive. We're multiplying by powers of 10. 5 times, it's going to get it larger and larger and larger by 5. So we're going to go under the 3 and the 5. That counts as 2 jumps. And then we need 3 more. So we're going to put 3 zeros. And so our answer is 135,000. But when it's a negative exponent, we're going to move to the left 5 places. So we have to go under the 3, and then we need 4 zeros in front of that. Put your decimal, and then put that front 0. You always want that front 0 to appear so that you can really tell someone that you had 0 point something. It's very important. And because our original number was negative, this should be negative. Count our numbers back, 1, 2, 3, 4, 5 to get in the original location. We got it. Now, how do you multiply scientific notation? Let me see how many scientific notation we got. Well, we're almost done. Okay. So we're going to multiply the numerical portions together using a calculator, and then we're going to multiply these just using what we know about common bases. So if we do 5.71 times 2.94, we get 16.7874. And then we're going to do times 10. We're going to use the common basis of 10. When you're multiplying, you add the exponents. 8 plus 3 is 11. Now, it is not in correct standard or scientific notation form yet until our decimal place is there. So we have to move it one over. It was more than 10. So we have to add one on to that number. So it's going to be 1.67874 times 10 to the 12th. So if it was too small, like if it's 0 point something, we had to move it that way, we would subtract, but here we have to add one on. Question 37. A medication is dosed at 8 milligrams per kilogram. What is the dose for a person weighing 32 kilograms? So we need 8 milligrams per 1 kilogram. So how many milligrams for 32? So just set up a proportion. We're going to cross multiply. 8 times 32 should be 1 times x, or x. 8 times 32 is 256. So that's 256 milligrams. Let's look at 38. Convert 4 feet 8 inches to centimeters. Now, I would suggest changing it all to inches, okay? So 4 feet times 12 is 48 inches. But they're 4 feet 8 inches, so that's an extra 8 inches, or that is 56 inches, okay? Now you need to know that 1 inch is 2.54 centimeters. So that is your next conversion fact that you want to know, okay? That 1 inch is 2.54 centimeters. So if 1 inch is 2.54 centimeters, 56 inches is X, how many centimeters, okay? So we're going to cross multiply. 1 times X is X. 56 times 2.54 is how much? So if you put that into your calculator, 56 times 2.54 is 142.24 centimeters. So first, to make it a common unit, in this case, inches, every foot has 12 inches in it. 4 times 12 is 48, plus 8 is 56. And then 56 inches is how many centimeters? 142.24 centimeters. And our last question, we're going to go backwards. Okay, so we still have to use the fact that 1 inch is 2.54 centimeters. So let's put that in a fraction form. 1 inch is 2.54 centimeters. So how many inches is 75 centimeters? So again, cross multiply. 1 times 75 is 75. X times 2.54, just stick that in front of the X to remind you that that's what you're going to divide off. We're going to divide both sides by 2.54 because we need 2.54 centimeters to make 1 inch. So when you're going from a smaller unit to a larger unit, you end up dividing by that conversion factor. So 75 divided by 2.54 is 29.527. And after, let me just put that like that. And that would be inches. Since, it depends on what you're going to do with this information. Watch how they want you to round. Let's round to the nearest tenth. Well, let's 100. Let's go 100th. Since our conversion was 100, let's go 2 places. And so the 2 now would become a 3. Okay. So that's the types of things that you want to study. See if you can do this by yourself. I will attach the PDF. I'll give you two things. I'll give you the blank one. I'll give you the finished one, and I'll also post, this video if you're watching it. So thank you so much, and come see me at office hours if you have any questions. Okay, bye.